Okay, I think we are good to go. So we will start with the session. So, hello everyone. A very warm welcome and good afternoon to all of you joining us from different parts of the world. And dear authors, distinguished session chairs, esteemed guests, welcome to technical session 6C. I'm Yashita and I'll be your moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, I extend a heartfelt welcome to the 10th World Conference on Information Communication Systems, Software Security and Sustainability, which is World S4 2026, and this is the 10th edition of the conference, which is conducted in a hybrid mode. The physical conference took place yesterday in London, and we are delighted to connect with you all virtually through Zoom on 29th and 30th of July. We have an exciting lineup ahead, and I'm sure that we'll have some insightful discussions and innovative ideas. So, a quick session guidelines before we start with the sessions. So, we will be having a total of 6 paper presentations, and each presenter will be given 10 to 11 minutes for the presentation, followed by 2 to 3 minutes for question and answers. And at the 9th minute mark, I will give a gentle reminder so that everyone can wrap up comfortably. And we kindly request everyone to stay connected with us till the closing remarks. If you have any questions, technical issues, or updates during the session, please feel free to use the chat box. Me and my co host will be assisting them. So, before we begin, it is my honor to introduce you all to our session chair for today. So, first we have Dr. Shalini Puri. She is an associate professor in the Department of Information Technology at Manipal University, Jaipur, with 20 years of teaching experience and 11 years of research expertise. She has published 31 research papers and actively participates in national FDPs, workshops, and training programs as well. Her research interests include machine learning, image processing, pattern recognition, and artificial intelligence. So, welcome to the session, Shalini ma'am. Would you like to say something to start the session?
Yeah, thank you for the invitation. You can proceed. Thank you.
Okay, sure. So I think okay, our next second session chair for today are Dr. M. Shamim Kaiser, a professor at the Institute of Information Technology within Jahangirnagar University, Bangladesh, with over 14 years of professional experience in advanced IT academics and university leadership. His core research interests span data analytics, machine learning, wireless sensor networks, and cybersecurity. So he will be joining us in a bit. Till then, we will proceed with today's lineup of presentations. So for our first presenter for today is Anna Borko Boateng. She is here to present her paper titled as AI Assisted Occupational Safety in Informal E-Waste Recycling, a Software Engineering Perspective. So Anna, are you present in the session?
Yes, I'm right here.
Yes. So you can start sharing your screen.
Thank you.
Yes.
A bit difficult is why it's not giving me the application I want to show.
Is your presentation open in some other tab? It should be open.
It's open in an application, but it's not showing me the app as usual. Let me... Here. Okay, found it. Oh, I had some... I had some... it says I need to restart. I'm not sure. I'm not sure. Let me
Okay,
try it
so what
again.
we can do is
Let me
you
try.
can solve your issue, then we will move with the next presentation and then come back
Oh,
to
let
you
me
again.
see if it opens
Oh,
now.
yes, it opened. Yes. It is visible
Okay, and you
actually.
can see it now.
Yes, just turn on the slideshow
All right.
mode.
Yes. All right.
It's perfect.
So, hello everybody. My name is Anna Perko-Boateng and I come from Tampere University in Finland. And we have been researching AI assisted occupational safety in informal e-waste recycling. And here is our software engineering perspective about it, what we found out. So I'd like to begin with a simple thought experiment. Like, imagine that this is your workplace. Every day you dismantle old electronic devices by hand. You don't have formal safety training. You don't have an occupational safety officer standing next to you giving instructions. But there is something you have that almost everybody carries today, which is your phone, a smartphone. And that simple observation became the starting point of our research. So AI meets a different reality. It has become remarkably good at recognizing images nowadays. So, but always, or usually, the AI systems often assume that we have these specific things in place, like modern devices, reliable connectivity, experienced users, structured environments. But in informal e-waste recycling, many of these assumptions do not hold at all. So workers may use low-cost smartphones, the connectivity may be unstable, or it's too expensive, for example. And the working environment is both unstructured and hazardous. So we realized that the accuracy was not actually our biggest challenge, but the design itself was the challenge. And what we did was that we first created a needs assessment with real workers, informal workers in this e-waste area. And we started by understanding what do they actually need through these interviews. And based on these findings, we designed and implemented a prototype. It's an Android prototype, and the prototype was first evaluated in laboratory conditions and then tested in field conditions in Accra, Ghana. And throughout this iterative process, we noticed that some design decisions came up again and again. And eventually, these became the 5 design principles that represent the main contribution of this work. So here's a small set of screenshots of the running application. These are taken in the laboratory settings. So the app takes a photo, you wait a few seconds, receive a safety guidance from the AI, and behind that simple interaction, there's an important architectural decision. For example, the phone performs only lightweight processing while the computationally intensive AI runs in the cloud. And then this allowed that the system works on all low-cost Android devices and will still benefit from the powerful multimodal AI models. The prototype was then evaluated with 12 informal e-waste workers at 2 different recycling sites in Accra, Ghana, using their own smartphones. And then something unexpected happened. The prototype was no longer the most important outcome. We had different manufacturers, different Android versions, different levels of digital experience. So it was less of a controlled experiment at this point. So what happened was that we realized that the application itself was no longer the most important outcome. But we had found out something more important. And here are our results as 5 reusable design principles. So first, the cloud inference was needed because the target devices had limited computational capacity. So heavy interpretation was moved to the cloud, while the phone handled only lightweight image pre-processing. And this allowed the application to operate across older and low-cost Android devices. And second, the AI output was structured into predefined fields. And in a safety critical application, the interface must reliably know where to display the detected item, risk level, warnings, and handling instructions. So the structured output also limits all kinds of irrelevant or overly verbose responses. And then the third, the prompt had to explicitly define the occupational context. So without this framing, the model produced consumer-oriented advice, which was of course wrong because these people are working. They are actually the people dismantling these e-wastes. So with the context that we're prompting, the guidance focused instead of dismantling hazards, instead of general advice like take it to the recycling center to dismantling hazards, toxic materials, and protective measures they could take during their work. And then fourth part is that the risk was communicated through color and icons and text labels. So this was important because users differed in literacy and visual conditions also differ, maybe light, maybe dark, and so on. And familiarity with interface conventions is also a possible problem. So no single signal should carry all the safety information, but use many of them to get the message through. So finally, the workflow was kept very linear. So there's a welcome screen, camera, preview, and result, and nothing else. No menus, no settings, no branching paths. So all participants completed this workflow without prompting. They don't have to know how to use AI. And this supported the value of a very simple task-focused interaction. And then, so field evaluation results, we had 12 participants, we had 12 different smartphones, everybody completed the workflow, and 11 out of 12 rated it very useful. So these results gave us some confidence that the principles were not only theoretically sound, but actually useful. So beyond e-waste, although this study focused on informal e-waste recycling, we believe that these design principles are actually transferable to many other domains also, meaning, for example, all kinds of challenges whenever AI is used to support people working in demanding environments with limited resources. For example, construction workers may need guidance for hazardous materials. Agricultural workers might require support when handling chemicals or identifying risks in the field. Emergency responders often need rapid, reliable information under stressful conditions. And in all of these settings, the same design questions remain. How do we make artificial intelligence understandable, reliable, and usable in the real world? So we believe that these 5 design principles provide a practical starting point for designing these systems. So to conclude, our work shows that designing AI for low resource environments actually requires more than accurate models, and it requires careful attention to the context, usability, and communication. And therefore, we hope that these 5 design principles can support the development of future AI-assisted occupational safety systems in many different domains. So thank you very much for your attention, and I'd be happy to answer any questions.
Shalini ma'am, any questions from your side?
Yes. Hi, Anna. Nice presentation. My question to you is, your work applies AI to occupational safety in e-waste recycling. So how does the proposed system handle uncertain, incompletely, or high variable data typically encountered in informal recycling environments?
I'm sorry, I was not able to hear it so well.
Okay, my question is, how does your system handle incomplete in uncertain or highly variable safety data?
Incomplete and what?
Data, incomplete or uncertain data. How your
Uh,
system can handle it.
yes, incomplete data as coming from the AI or as being given put as a prompt.
Pardon?
If I understood correctly, are you asking if the data is incomplete coming from the AI or incomplete going where the AI is going to interpret it?
Wherever you are using data, if it is incomplete, how your system is handled.
In this version, this was a prototype, and we wanted to create something that to see if it's actually even workable. There's a lot of problems still, and one of the problems is to limit the data, for example. So we have not done for this system, we have not done qualification like quality checks for the output. What is the AI producing? But it is able to recognize quite smudged e-waste. If you send a little bit smudged photo, it will still make quite a good guess. But those are things that do require more research.
And one more question is there. How do you ensure that AI-generated safety recommendations are explainable?
How do I ensure that what?
Yeah, AI-generated safety recommendations are explainable actually.
The last word, I missed that one, sorry.
My
That
question is, how will you ensure that AI-generated safety recommendations are explainable?
Explainable.
Yeah,
explainable.
Yeah.
yeah.
Yes, well, I don't know how to make 100% sure that it is. Because there is a very detailed data, and there is a restriction how much it's allowed to give. And also, there is another problem because how literate are these people that are working with this app? So you have to oversimplify sometimes some things to make the message clear. So this is something that really has to be researched a little bit deeper.
Okay. Thank you.
Very good question, yes.
Thank you so much, Anna, for your presentation. You can stop sharing your screen.
Yes, thank you.
Yes. So for our next presentation, we have Oksana Kharchenko. Oksana, are you present in the session? Actually, I can see her, but yes, okay, she is presenting.
Hello,
Yes.
everybody.
Hello.
Have not presentation. Ой, а where am I? Вот, помоги мне.
Где у тебя?
Она?
Боже мой.
Вот, here. Hello, do you see my presentation?
Yes, ma'am, we are able to see and you can start.
Hello, everybody. My talk is devoted the application of Hilbert-Huang transform to non-stationary signal processing. Many traditional statistical methods are based on the theory of stationary random processes. One of the main tools is the Fourier transform, FT, but real physical signals are often non-stationarity. They change over time and are observed only for finite duration. Because of this, we need methods that work better with non-stationary data. I will show several methods using examples from drone acoustic signal and electroencephalogram recording. The first considered method is window Fourier transform. WFT. The Fourier transform gives only a global spectrum and does not show how the frequency content changes over time. To solve this problem, the window for windowed Fourier transform was introduced. It applied a window to the signal and computed the spectrum inside this window. Next slide. This slide shows windowed Fourier transform on the drone's audio signal. In this figure, we observe change of frequency over time. Next slide shows the windowed Fourier transform of the EEG of the healthy adult and a sick patient. We see in the patient case the energy is concentrated in a low frequency range. The healthy adult have a strong alpha rhythm. The next method under consideration is wavelet transform. The wavelet transform improve resolution. It uses wavelets instead as sinusoids. Wavelet transforms give a better time frequency representation of the drone's hour signal. It's in this figure. In also EEG. We can see EEG of a healthy adult and a sick patient. In these cases, wavelet transform shows clear localization of the rhythm. Wavelet transform is better than window Fourier transform, but still has limitations. If the signal is narrowband, then it was a wonderful property. It can be represented with a high accuracy in a follow forms. This method connection between A, F, and S term is established using Hilbert transform. This method provides greater accuracy in terms of time localization. However, the narrowband requirement greatly limits the possibility of using Hilbert transform. Nord and Huang proposed a way to improve the narrowband limitation. He decomposed a wideband signal into intrinsic mode function. Each intrinsic mode function is narrowband, so we can apply the Hilbert transform to each of them. Figure 5 shows the intrinsic mode function from drone's audio signal. In radio engineering terms, the intrinsic mode function represents frequency modulated oscillations. Next figure shows the Hilbert-Huang spectrum of the drone's audio signal. In this case, time localization is good. It is obvious that the frequency interval is narrower compared to the wavelet transform. This indicates that Hilbert-Huang transform provide better frequency resolution compared with wavelet transform. In the drone example, the Hilbert-Huang transform shows a narrow and more accurate frequency interval compared to the wavelet transform. Next slide shows marginal spectrum of Hilbert-Hahn transform. The marginal spectrum is an integral measure of how the signal's energy is distributed over frequency. We compare the marginal Hilbert spectrum and the amplitude spectrum based on Fourier transform. From the drone's audio signal. Marginal spectrum and amplitude spectrum based on Fourier transforms the drone's audio signal shown in this figure. The marginal Hilbert spectrum appears different. Compare the corresponding amplitude spectrum. Here different. It is observed that frequencies above 3 kilohertz are missing in the marginal Hilbert spectrum. At the same time, it can be noted that the graphs correlate. The next figure is very interesting. The marginal spectrum and Fourier-based spectrum differ. Marginal spectrum, blue is Fourier spectrum. This is evidence that the Fourier transform is not suitable for non-stationarity signal because it assumes stationarity and therefore distort the true spectral structure. In figure 9, the spectra look
Ma'am, just
similar.
a quick reminder for you that you will have to wrap up in next 1 minute.
Не поняла. Долго что-то?
Ну, только рисунок.
I mean, you
ну,
can just
не-
summarize the rest of the things because the aim is to like understand the core idea only. So yes.
Ну, вроде... Ну, в общем, main conclusion, Hilbert-Hahn transform provide high time frequency resolution that windowed Fourier transform and Violette transform. Hilbert-Hahn transform is more accurate for non-stationary signal, such as drones, acoustic signal, and AG. And the marginal spectrum does not always coincide with the Fourier spectrum because Fourier transform assumes stationarity, while real EEG signal and drones acoustic signals are not stationarity. Thank for your attention.
Yeah, thank you for the presentation. That was a nice presentation. I want to ask, what was the data set size for your study? Am I audible?
Yes, ma'am. Just the background noises are more. So can you repeat?
Yeah. What was the data set size for this implementation?
Всё, я и так, что ли, выключается? Нет, я не могу выключить.
Вот там стоп-шор это.
А я просто его закрою и все.
Ma'am, would you like to answer ma'am's question?
Что видите? Теперь вопросы будут.
Ага. Ну, я думала, что...
Должен просить.
Shalini
Ну,
ma'am,
что
can
вы-
we move forward then?
Yeah, okay, fine. Thank you.
Okay. Yeah. Thank you, ma'am, for presenting. Okay, so for our next presentation, we have Puvis Thiparakul. Puvis, sir, are you present in the session?
Yes.
Yes, so he's here with us to present his paper titled as Enhancing Team Collaboration in Game and Animation Projects, a User Experience and HCI Approach to Workflow Design. So, sir, you can start presenting. Also, a small request to all the presenters that you have to wrap up within 10 minutes as we are time bound and have to finish all the presentations in the given time. So, yes, sir, you can start.
Okay. Here. Okay. Did you see my slide?
Yes.
Okay, thank you. Okay, I'm ready. Hi everyone, and thank you for having me today. My name is Puvis Tipapakun. I'm present my research from digital design at King Mongkut University Technology Thonburi together with the Digital Innovative Design Technology Center. The title of this research is Enchanting Team Collaboration in Game and Animation Production by a User Experience and HCI Approach to Workflow Design. And this research is also starting point of a real product for WorldS4. I will show you later. Here is what I talk today. So the first, the problem we found and the gap in current research. And second, our method and our research question. Third, our new idea called the waterfall storm model. Fourth, how this research become a real product. Fifth, the result of testings. And the last is conclusion and future plan. Now, game and animation production today is very complex. One project can involve many studios working together. This makes it hard for project manager to see the full picture, but the big studio can pay expensive tools, but the small and medium studio cannot. So many teams end up using different tools and different format. This creates a confuse and it creates a mistake and it in a cost and time planning. What does is happen? Most of project management tools today are made from generic business use. They follow a common framework like Scrum or PMP, but game and animation work is different. It's based on creative assets, not just a simple task. So teams are focused to make their own spreadsheet outside the system. This adds extra work and it also break communication between the studio. To understand the problem better, we look at exist research. Project-based learning is a well-known method. It helps students learn by doing real work. Game-based learning use user rules and feedback similar to real production. Agile method also fit well because creative works always change, but there is one big problem. All these methods assume that a good tracking tools already exist in a real studio. This is often not true. This is a research gap our study want to fill in. This slide is the center of our design thinking. So let me expand about this one. We using user experience and human-computer interaction principle to guide the system design. One important idea is Jacob law. That he says the people prefer a new system to work like system they already know. This make learning faster and easier based on this law. We focus on 4 design areas. First, information layout organized on the screen so user see the big picture at the bottom. Second, icon and navigation. Using a simple, clear icon so user do not need to training. Third, error prevention. For example, linking an asset directly to a task so nothing to get lost or duplicate. And fourth, better team communication. Using one sharing format so everyone in studio understand the same information at the same way. These 4 ideas guide every design decision in this project. To confirm this problem is real, it's not just a theory. We interviewed Solarak Wongseli. He is the owner of East Studio that make animation company in Thailand. He told us that the team often choose tools based on personal habit, not on a standard method. This creates a real problem: wrong cost calculate, wrong timeline, and poor monitoring. So this interview confirmed exactly what we expect from this research. So this brings us to our main research question. Does a domain-specific project tracking system designed with UX and HCI principle improve team workflow, project control, and cost estimation? To begin, and for small to medium studio, this is the question our whole study tried to answer. To answer this question, we used a design-based applied research approach. This method has three stages. First is system design. We build the framework layout using UX principle, easy to read, low mental effort, and error-proof. Second is implementation. We deploy this design on a real demo website so people can actually use it. Third is evaluation. We collect real data from real users in both school and industry setting. This three-stage process connect theory direct to real practice, and it also explain how we collect our data. Our design came from real people, not just our assumptions. We collect quantitative data through interviews with three groups. First, studio entrepreneurs. They want a clear, auditable system, but they cannot pay high per user fees. Second, practitioner and project manager. They want a simple pipeline view and they want to assign tasks without long meetings. Third, undergrad student. They want a simple system possible. These interviews are the foundation of our whole design and they directly shape the model. From this interview, we create a new concept called waterfall storm model. The word waterfall means the structure high-level part like template, milestone, and audit trail for manager. The word storm means the fast, flexible path where the team member create and finish tasks quickly every day together. These two parts give one dashboard for everyone without switching between many tools. This model also adapts to different industry. For game project, the system use milestone tracking and clear separate artwork from programming work. For animation project, the system use a shot-based structure. Every task has access connect to one specific shot. This design choice act like a safety net. It prevent missing or duplicate work. Now, here is an important point. This research is not just only theory. The waterfall storm model, which we test individually and became a foundation of a real product called Core4. So you can go to the website core4.com to check it. Today, Core4 is a live studio management platform. The waterfall layer became real feature like project milestones by live studio and rich management. The storm layer became
Sir,
task,
a
comment,
reminder that you will have to wrap up in next 1 minute.
okay,
Yeah.
asset register and notification. So now I have like a testing 100 user over 30 project and with two environment. The result in the classroom, the student understood project workflow much better the structure. In the real studio, the results are also strong. Every team member can their own task without waiting project manager. So what does the research contribute? First, domain specific design is balanced, structure, and flexible. So to conclude, a domain-specific system designed with UX and HCI principle clearly improve team collaboration and task visibility and cost control. So additional sorry, for both student and small studio. In the future, we plan to test with the large production team and add automation analytic and apply UX law in the future. Thank you very much.
Thank you, Dr. Quiz. Wonderful presentation. My query is, how did you evaluate the effectiveness of the proposed workflow design quantitatively? Just an example, through task completion time, communication overhead, productivity, or user satisfaction. And what evidence demonstrates improvement over existing workflows?
Okay, I didn't catch the word query, but I tried to answer. Can you uh, say that again, please? Sorry.
Ma'am, could you please repeat the question for him?
The word it doesn't query
Yeah,
for me.
sure,
Sorry.
sure. My question is, how can you evaluate the effectiveness of the proposed workflow design quantitatively?
Okay.
And secondly, what evidence demonstrates improvement over existing workflows?
Okay, thank you for these questions. I use the evidence like right now some information is under NDA because I am testing with the real production. So we test on the real production work like uh, the character animation in one part and the other with the old style tracking platform and at the same animation part but it's different chapter but the work task is the same. The project manager doing the same thing but different too. When they use the call for and this method, they work fastly like one animation they use like a 7 day, but they can track. They use the waterfall storm model by 4 to 5 days to finish their work and publish to the internet or uh, somewhere that they can do. And the quantity that I choose is like a that I do like a because in this platform, if you go to that, I decide to correct all the data that how performance on each studio and each person do and fix and find the solution to fix what the problem when they do like these people use like a 3 hours work to work with the old style tracking platform but they use but the other hand they use the call for we found that they're doing on 3 hours work and we found the problem why they use 3 hours. Mostly it should be finished on 1.5 hours, sometimes like that, some kind like that. So we try to track every single one person in the platform, and project manager can solve the problem and find the solution to fix directly and can order them uh, to do the right way for that task.
Yeah, okay, thank you.
Thank you.
Thank you so much, Povis, for your presentation. You can stop the screen sharing.
Okay, thank you so much.
Yeah. So for our next presentation, we have Dhaya Edine Sali, who is here to present his paper titled as Intelligent Edge-Based Facial Recognition for Real-Time Student Monitoring in Smart School Transportation using IoT and Hybrid Deep Learning. So, sir, are you present?
Yes, I'm here.
Yes. So you can start
Okay.
your presentation.
Okay, thank you very much. So this is my presentation. First, sorry for the camera. I couldn't turn on the camera.
That is totally
My
fine, sir. You can
presentation.
continue.
Okay, thank you very much. So my presentation is intelligent agent-based facial recognition for real-time student monitoring on smart school transportation. I present this first. Thank you for giving us the opportunity to present in your conference. Our outline or our plan, we begin with the motivation, small motivation. We talk about the real work and the gap between the real work and our proposal. We give you our proposal and we move to the implementation results and we finish with a small conclusion. In the school bus transportation, every time we have problems. We have many human errors like children, etc. No automotive proof. That means we have any warranty about the children if the children enter or leave the bus, etc. Sometimes we forget some children inside the bus. Sometimes the parent couldn't track the buses to مثلا to achieve or to know what is place of their children, etc. From here we have our work is to build a system or to track the buses and with the real-time tracking and the real-time face recognition inside or outside the bus. So we have many works we have many works on this field. Sometimes we found some works on tracking the GPS. Sometimes we found some works on the face recognition, but we didn't find any work to combine the two solutions together in one system with real-time notifications, parent notifications, etc. This is our goal to in inside in the work. Now our contributions. We begin with IoT architecture. After that, we have built six models, AI models. We choose our CNN LSTM hybrid with accuracy 99.5 accuracy. And our data set, it's around for 40,000, sorry, 40,000 images. We use many hardware, many software. Now we try to work or we try to explain each one. Now in our proposal on our IoT architecture or our architecture, we have the sensing layer. This is our first layer. And when we use CAM integrated in ESP32, I use GPS to track the buses. We send the data via ESP32 board. This gateway is give us the warranty that our data is secured, our data is arrived at time. Using the HTTPS MQTT, we found or we sent data to a cloud inference or to the cloud server. In the cloud server, we organize our data. We build our model. We try to build our model with face recognition and the tracking system in real time. After that, we have some application layer. The application layer, we have two applications, one for the parents, one for the school administration, and one another for the driver, the to just to modify the current situations. Now our design choices by layer for the sensing, we use ESP32 integrated with a CAM plus GPS. The ESP32 CAM is just to keep or to take pictures in the door of the bus, just to take the pictures, sorry. And the GPS was just to track the bus in real time. The gateway, we have MQTT and HTTPS to encrypt and to send and to encrypt and send. After that, to receive and decrypt the data. For the server, we use a cloud server, basic cloud server. And for the app, we use mobile app. We are just to give the UX for different stakeholders. Um, for the hardware
Sir,
iterations, or we
sorry to
have or
interrupt. You will have to
yes,
wrap up in next 20 to 30 seconds. Just summarize the rest of the PPT.
okay.
Yeah.
Just for the hardware, we tried many combinations, and the last one is the ESP32 cam with the ESP32 cam with MQTT and HTTPS. For the AI pipeline, we have data preparation. We have overall 40,000 after cleaning, etc. We have 30,000 images. After augmentation to 40,000 images, we augmented. We have the second step, pre-processing and modeling. For the LSTM, ACNN, LSTM hybrid architecture, now we talk about the CNN just to prepare our data, LSTM for temporal modeling, and we build our to build our model. For the results, we tried many models as basic SVM, PSA, distance classifier, random forest, etc. The most efficient one is CNL LSTM hybrid with accuracy is 99.5 as accuracy in the final stage. So this is the number of epoch when we tried our model. Finally, we can achieve 99.5 accuracy in our models. This is our confusion matrix. And you can see, and we have only 40 pictures, not only 40 pictures, not predicted or not tested. So from here we can as a conclusion we can say no, for the accuracy for the model is CNN LSTM 99.5 accuracy. As that data set is 40K images augmented images. For the timing is end-to-end latency is 87 milliseconds. And for other architecture, we have four architectures. One for the IoT, AI applications, and cloud computing to store the data. For the future work, we have to encrypt. We try to encrypt the work. We try to make it real, our app, and we try to use multi model or to use another models to send or to try our work, inshallah. This is thank you very much, and I'm ready for any questions.
Yeah, thank you for the presentation. Nice presentation. My question is, since facial recognition is being performed at the edge in a real-time transportation environment, so how does
Yeah.
your system balance recognition accuracy, latency, and energy consumption?
Dr. Shireen, can you the last part of the question?
Yeah, I'm repeating my question. So, like,
Okay.
this is about face recognition. So, how your system is managing accuracy, latency, and energy consumption?
Okay. Honestly, in our work, we focused only for the face recognition, or not on the energy, but on the latency. We try to work with a hyperparameter of CNN LSTM every time to change the configuration until we found this accuracy.
Okay. My another question is like this is like face recognition. So in this system, how does your proposed architecture address the privacy, data protection, and security risks?
If I will understand your question for the and if to propose this approach or this proposed approach, it's to how to send in real time the images from the hardware to the software or from to the server cloud in the real time the data is protected and encrypted يعني to send it to the cloud server. يعني I don't know if I will understand your question.
Yeah, but you know that like face recognition and such recognitions actually requires some data privacy as well. So
Mhm.
how your privacy, everything is being maintained here.
For the data set, you think?
Yeah, data set or like, in case we are sharing some, this is something like confidential data or maybe some data related to a person. So data privacy or facial recognition, some biometrics or something is like that will be there. So how such privacy will be maintained using your app or using your system?
Okay. Yeah, by using the system, we have some algorithms of encryption of the data. That means, before then sending the data in the gateway, we try to encrypt the data. After that, we decrypt it in the cloud in the server. That means, our data is not allowed for everyone. It's protected.
Okay, thank you.
Thank you.
Okay, thank you so much, Purs, for presenting.
Thank you very much.
Yes, thank you. You can stop sharing your screen.
Okay.
Okay, so for our next presentation, we have Mohammad Istiaq Ahmed Bhuyan to present his paper titled as Performance Study of an Autonomous Two-Wheeled Self-Balancing Robot Using Deep Q Network. So, Istiaq, are you present in the meeting?
Hello, yes. Can you hear me?
Yes, you are audible. You can share your screen and start with the presentation. Check. Yeah, your presentation is visible.
Yeah, yeah,
Your notes are also visible.
Is it okay now?
Yes, it is fine, but you can start.
Uh, this is Istiaq Ahmed. Today I am going to present my research entitled Performance Study of Autonomous Two-Wheel Self-Balancing Robot Using DeepQ Network. So this research basically investigate how DQN algorithm can be used to control an autonomous two-wheel self-balancing robot. So here is my today's presentation outline. Uh, the two-wheel robot self-balancing robots are an interesting class of mobile robots because they combine excellent maneuverability with and compact mechanical design. Since they balance on only two wheels, they can perform zero radius turning and navigate narrow environments more efficiently than many other conventional mobile robots. However, these advantages also introduce and major challenges. For example, a two-wheel robot is naturally unstable. So looking into the literature review, the first study by Chen and colleagues proposed an adaptive double fuzzy PID controller that successfully enabled the robot to climb slopes up to 29 degrees. However, the controller remained based on classical adaptive control, and they did not explore the deep reinforcement learning. The second study by Rahman and co-authors introduced Q-learning and DQN for balancing a two-wheel robot. Their work also demonstrated that DQN achieved higher accumulated rewards than conventional Q-learning. However, their evaluation mainly also focus on pitch angle stabilization in simulation, and they did not investigate roll recovery performance under different disturbance. The third study by Lee and his co-authors compared Q-learning, DQ, and DDPG. Their results showed that DQ and DDPG produce smooth convergence and higher rewards than Q-learning. Nevertheless, the study still did not analyze the robot's operational limits and failure mechanism under extreme initial disturbance. From these studies, it is clear that most previous research concentrates on successful balancing, while relatively little attention has given to identifying the boundary condition where the robot eventually fails. The basic problem of a two-wheel robot is naturally wants to fall over. It needs a computer to make a constant adjust to stay upright. Traditional methods like PID, LQR, fuzzy logic method only work well in the control situation. So newer AI model methods can successfully balance these robots, and the most research only highlights the successes, but still the most of the paper does not explore the absolute limits of this AI, or exactly how and why it fails when it gets pushed too far. So our research basically have the four objective. First one is develop a DQN based controller. Second one is, since DQN is a discrete type algorithm, so we used EMA filter, which is means exponential moving average filter, to smooth the action. Third objective is evaluate the performance under like initial different pitch disturbance, and last objective is analyze the failure mode at boundary condition. So here is my robot. So the robot parameters are as shown in the table. The chassis mass is 5 kg. Overall, the robot mass is 7 kilo. So in the experimental details, in this work we actually use the DKN agent observed toward the state vector representing the robot's current condition. Uh, the observation includes the robot's position, like or position, orientation angles, linear velocities, angular velocities, and the rational speed of both wheels. Therefore, each wheel is assigned one of 7 normalized torque levels ranging from -1 to +1. By combining the 7 torque levels for the left wheel with the 7 levels of for the right wheels, the controller obtains 49 possible actions. So one challenge with a discrete action space is that the selected torque can change suddenly between consecutive control steps. These abrupt changes may produce oscillatory behavior, mechanical vibration, and unstable robot motion. To overcome this limitation, we introduce exponential moving average or EMA filter, as we can see in the equation 2. In this study, the smoothing factor alpha is 0.25 is used, which means it blends 25% of new commons with the 75% of previous commons. So here is overall my experimental methodology flowchart. So first we initialize the simulation environment, then initialize the state, then or observe the state. After observing the state, we apply the DQ algorithm. From the DQ algorithm, we getting the torque index, and we map the torque index according to the torque mapping chart. So after that, we apply to the EMA filter into the torque. So uh, after getting the result of EMA filter, we directly applied to the result in the two wheels for the torque. And then we check, then our algorithm check, is it cell balance? Our cell balance condition is pitch or roll angle is less than 40 degree. So if it is cell balance, is going to continue the simulation until the maximum alloyed steps, then is calculate the reverse, and we and it reset the environment also, and also calculate the reverse and going to end. If not is cell balance, so it getting the penalty, and also this penalty getting also the in the reorg calculation, and also when it not balanced also, this is stored the transition. So after storing the transition, eventually it reset the observer environment, and also again start the next episode. So here is my result. We actually tested in four initial pitch condition, which is 0 degree, 15 degree, 18 degree, and 20 degree. And each condition also tested in 4 times. So we can see in the figure 2, like four tested graph is here. So from the 0 to 18 degree condition, the robot maintain near perfect equilibrium with small oscillation and consistent recovery performance. But when it comes to the 20 degree initial pitch condition, the out of four tested, three test run was failed. Why is failed? Because when 20 degrees initial pitch condition, the roll actually is over 40 degree is over 40 degree, as we can see in the figure 6. Its tilt angle is 41.3 to 40.12, and again another one is 41 degree. So in the meantime, the reward also is dropped. So this is the basically reason why is failed. So exponential moving average filter effectively reduce abrupt torque changes produced by the discrete action space. This resulted in smoother wheel motion and improved transient response during the balance recovery. Although the proposed controller performed well in the simulation, there are several opportunities to future improvement. One of the possible direction is to replace the discrete action DQN with the continuous action reinforcement learning algorithms such as SAC or TD3. Thank you. That's all from me.
Thank you so much, Istiak, for presenting. Shalini ma'am, any questions from your side?
Just one question. How does your DQN controller compare with PID or model-based control under real-world disturbances?
Okay, so basically the DQ and the PID and others controller, uh, uh, they produce the result is like we can stabilize in the under the 40 degree 40 steps, but in other research paper it takes more steps to uh, stabilize. Uh, so this is one of the reason we came to in the reinforcement learning, and 15, 18, and 20 degree disturbance we only tested. We couldn't find in any research paper they are testing with this initial condition. I hope
Okay.
I explained it.
Yes. Okay. Thank you.
Thank you.
Okay, thank you so much. So you can stop sharing the screen. So for our last presentation for today, we have Prince Kelvin Obusu. Are you present in the session, sir? Okay, let me check once.
Can you hear me?
Yes.
Okay, so my name is Gilson, and I'm presenting on how strengthening campus area network through VLAN segmentation and then access control. We are taking evidence from Pentecost University, Ghana. So, campus area networks are important because they support almost every activity within a university. They connect students, lecturers, administrative staff, and databases and online services. However, when a university network is poorly segmented, users and devices may have unnecessary access to sensitive resources. So, weak access control, insecure wireless connections, and limited monitoring can also increase the risk of cybersecurity or cyber attacks. So these challenges are becoming more important as universities. They are becoming more important as universities in Ghana are dependent on digital infrastructure and the dependence on the digital infrastructures increases. So this study therefore examined how VLAN segmentation and access control could strengthen the security and then resilience of the campus area network of Pentecost University. So previous studies show that VLAN can be divided into similar logical sections. This helps separate different users, departments, devices, and services. And then access control lists can then be used to determine which type of communication is allowed between these sections. Network monitoring also improves visibility and then supports faster detection of suspicious activity. So these approaches are consistent with the principle of least privilege and zero trust idea that users should not be trusted simply because they are connected to local network. So, however, there's a limited evidence showing how VLANs, access control, and then hierarchical network design and then monitoring can be combined within an operating university in Ghana. So this study addresses this gap by evaluating these measures in the actual network environments of Pentecost University. So our aim then is to strengthen the security and the resilience of the university's campus area network. To achieve this aim, the study first identified the weaknesses in the existing network. The network was then redesigned using the VLAN segmentation, access control, list, and then hierarchical network organization, and then improved monitoring. So the study also examined whether the intervention, that's the new introduced intervention, could reduce unauthorized communication between network sections. So finally, the security and performance of the network were compared before and after the intervention. So our methodology, the study used a mixed method and technical assessment approach. The data were collected from 268 students, lecturers, administrative staff. So interviews were also conducted with 10 members of the university's IT team or ICT team. The technical assessments also covered the importance the important network components, including routers, switches, firewalls, and wireless access points and existing monitoring arrangement. The study measured network conditions before and after the interventions. So the main indicators included the security incidents, latencies, and then packet loss, throughput, detection time, and then mitigation time, and also the last one, which is compromise rates. So the approach made it possible to evaluate both the security and operational effects of the redesigned network. So this is the redesigned network, as you can see. So the network was organized into separate VLAN based on the functions and security requirements of different departments. So office computers were placed in VLAN 10, and then heads of department and management users were also placed on the in VLAN 20. So the academic and academic and electronic library services were also placed on VLAN 30, while the accounts office also was placed on the VLAN 40. So the firewall, as you can see, the firewall and then the core network controlled communication between these sections. And then the VLAN created a logical boundary. So the VLAN created the logical boundary within the network, while the access control is determine which traffic could move across these boundaries. This design actually helped reduce unnecessary communication and limited direct access to sensitive university systems. So this is the VLAN and then access control. So the table presents the main VLAN and then their access control arrangements. So each VLAN was assigned to a specific network zone and then group of resource. For example, accounts office was separated from general office computers, and then academic service because it handles sensitive information or sensitive financial information. And then the cross VLAN communication was restricted by default. So only authorized services and approved traffic were allowed to pass through or pass between the sections. So this approach actually follows the principle of least privileges. Users and devices are given only access they need to perform their responsibilities. So therefore, even when one section of the network is affected, the attacker's ability to move freely from one or freely into other sections is reduced. So this is the security incidents results. So the results show a clear reduction in the security incidents after the intervention. So we have the DOS, which is the denial of service incidents, decreased from 420 to 160. So this represents a reduction of approximately 60%. And then the ARP, also, the ARP positioning incidents also decreased from 360 to 110. So this is also a decrease or reduction of approximately 69%. And then the DNS, which is the domain name between, also indicates or reduced from 420 to 210, so representing a 50% of reduction. So the overall total of the recorded incidents decreased about 1,200 to 480. So this represents a total reduction of about 60%. These findings suggest that VLAN segments and access controllers significantly reduce opportunities for unauthorized communication and network-based attacks. So let's see the performance and then the resilience results. The intervention improved not only security but also network performance and incident response. Latency decreased from 4.2 milliseconds to 2.8, 29. The latency decreased from 42.5 milliseconds to 29.8 milliseconds, while packet loss decreased from 2.1% to 0.9%. So network throughput also decreased from 155 to 155 megabyte to megabytes per second to 170 megabytes per second. The time required to detect an incident also decreased from 48% to about 18%. So mitigation time also improved significantly. So this decreased from 110 minutes to 35 minutes. And then finally, the compromise rate decreased from 5% to 1.7%. This results show that the redesigned network became more secure, more efficient, and more responsive to the incidents. So the discussion, therefore, the findings demonstrate that the network segmentation can provide practical security benefits within a university network by separating departments and services. The intervention reduces unnecessary communication between users and the users' device and sensitive systems. So the access control list also ensured that only authorized traffic could move between VLANs, and improved monitoring also helped the ICT team to identify and respond to incidents more quickly. Okay, so we move on to the recommendations. So these are our recommendations. So we recommended that based on the findings, the university should maintain the VLAN structure and then regularly review the access control list rules. Okay, thank you very much for your attention. Yeah.
Yeah,
Yeah,
thank you
thank
for presenting. Shalini ma'am, any questions?
Yeah, I have a question. How does your architecture prevent lateral movement after an attacker compromises the device within our VLAN?
Okay, your question is it how, okay, come again.
How does your architecture prevent the lateral movement after an attacker compromises a device within a VLAN?
Okay, so because we have the segmentations, once you get access to one, it prevents you from moving between one network to one segment to the other. Maybe one segment is compromised, it becomes really difficult to get access to the rest of the segments networks or the VLANs. This
Okay.
is the answer. Okay, thank you very much.
Yeah, got it. Okay.
Okay, thank you everyone. So this was the last presentation for today. And let me check once if anyone is remaining from the list. Uh, sorry. Okay, so we are good to conclude on behalf of the Global Knowledge Research Foundation and GR Scholastic LLP with the entire team of WS4. I sincerely thank all our authors for their excellent presentations, valuable research contributions, and active participation. A big thank you to all our attendees for making the session interactive and engaging. This is the 10th edition of World S4. We deeply appreciate your continued support over the years, and we look forward to welcoming you again for the 11th edition in 2027 as well. So, a few announcements to make. All presenters will be receiving their digital certificates through email within 2 working days, and the conference publication is expected to go live within 7 to 8 months. We kindly request your cooperation with the World S4 2026 team throughout the publication process. I would also like to express my sincere gratitude to our session chair, Shalini ma'am. Thank you for chairing today's session.
Yeah, thank you so much for the invitation. It was a good, in fact, a wonderful platform. Good research works are going on. I have only given some suggestions. They've already done very good work. Congratulations to all the participants.
Yeah, thank you so much, Shalini ma'am. This is a small token of appreciation on behalf of GR Foundation and Scholastic LLP. And once again, thank you everyone for your valuable time and participation. So before we conclude, there's one last request. I would like to like everybody to please switch on their cameras so that I can take a quick snapshot of the conference. Okay, thank you everyone. Stay safe and have a wonderful day ahead, everyone. Thank you. Thank you for joining.